In Unreal Engine, blueprints are excellent for doing fast iterations, but if you want full control, better performance, and cleaner scalability, it's time to learn how to combine blueprints with C++. And that's why in this video, we are going to build a simple feature twice. A pressure plate that opens a door when the player steps on it. We'll build it once in blueprints and then again in C++. Along the way, you will learn key concepts about C++ and how they differ from blueprints, and you will learn how both systems work together and when and why to use each. So let's get started. Alright, so let's start by creating a new project, and I'm going to start with the third-person template and also make it a C++ project instead of blueprint only. If you already have a blueprint-only project and want to add C++ functionality to it, that's fine. You can always do it later, and I'm going to show you how to do that later in this video. But since we're starting from scratch, let's pick C++, enable the starter content, and let's name it something like pressure plate demo. Alright, and now the game has opened up, and also Unreal Engine opened up my editor for me. This tutorial assumes that you already have Visual Studio or some other code editor installed for Unreal Engine. If you don't, I will be linking the guide on how to install Visual Studio for Unreal Engine in the description. Personally, I am using Rider, which is a JetBrains IDE, instead of Visual Studio. You still need Visual Studio installed because it comes with packages that Rider will still use. But if you do want to use Rider, which I find just to be a cleaner interface, I'm going to also link how to install Rider in the description. But to follow along from this point, you should have your editor installed and know how to run the game through the editor. So for example, if I close my Unreal project now and I want to run it from here, I just press the run button, it will build the project and then open it up. Make sure that you have these steps working before proceeding. Alright, so let's first build our feature in blueprints and then recreate it in C++. So our feature is going to include a door somewhere in the world and a pressure plate. When the player stands on a pressure plate, the door will open. So we need two actors for that, a door and a pressure plate actor. So let's go here into our content folder and let's create a new folder and let's call it Blueprint Actors because we're going to have C++ actors. And then we're going to create a new blueprints class. It's going to be an actor and we're going to call it BP underscore door. And this door is going to be very basic. It's going to have one component, which is a static mesh. And this is going to be the door mesh. Let's also drag and drop it on the default scene root so that this mesh becomes the root. And then the static mesh itself is the door that comes with the starter content. And this is our door. So if I place in the world, here we have a door. Oh, and by the way, this door mesh doesn't come with collision. So if you want to add collision to it, you're going to have to manually do that by going to the mesh itself, go to collision, say add box simplified. Now there's collision. All right. And now we want to add two functions to the door, one to open it and one to close it. So we are going to, let's delete this. We're going to use these later, but let's add one custom event called open door and another custom event called close door. So the way we're going to open or close the door is basically by rotating it. So if I rotate it 90 degrees, then it's open. If I rotate it from 90 to 0, it's closed. But of course, I don't want it to just snap to 90 and then snap back to 0. I want it to be smooth. So I'm going to keep incrementing this angle, let's say by a value of 2 degrees on tick, so that it happens smoothly. So the tick function will be responsible for this. But the open and close door functions will be responsible for telling the tick function what to do. Let me explain. So the open door function and close door function will set a variable. So we're going to have a new variable on the left here that's called should open or close. It's going to start as false. And when we call open door, we're going to set it to true. When we call close door, we're going to set it to true as well. So both of these functions just enable this variable or set it to true. Now, when this variable is true, the tick function then will check. So we'll do a branch and we'll check is this variable true? That means that I can proceed with opening or closing the door. And to open or close the door, we just set the actor's rotation. And we're going to split this. And we're going to get the actor's current rotation and split this as well. So we're going to keep the x and the y the same. We only want to rotate on the z-axis. So take the z-axis and add a value of 2 to it. So this will rotate it by 2. But remember that now we're just adding 2. So we're moving it from 0 to 90 by increments of 2. But closing it is subtracting 2, not adding 2. So how do we make this to a variable? Well, let's right-click and promote it to a variable and call it the yaw increment. And this yaw increment will change depending on if we're opening or closing the door. If we're opening the door, the yaw increment is 2, because we want to increase it by 2. But if we're closing the door, the yaw increment is -2. And that is basically it for these open and close door functions. Now, right now, if we do this, it will work, but we don't have a stopping condition. That means the door will just keep opening forever. So let me show you. So if I just call open door now, when I start and I play from here, the door will just keep rotating because we don't tell it to stop when it reaches 90. And it's going to be the same for a closed door. So what we want to do is to tell it if you reach 90 or 0, depending on what the yaw increment is, then stop. So let's write some conditions. So we're going to check, we're going to do a branch here, and we are going to check if the yaw increment is greater than 0. So remember, if we're opening the door, it's +2. If we're closing the door, it's -2. So if it's greater than 0, then we're opening the door. So if the yaw increment is greater than 0, and the get actor rotation z value is greater than or equal 90, because that's when it's open. If both of these conditions are true, so do an AND. So if this and this are true, that means that we are opening the door and we reach the end. But we also want to check for the condition if we're closing the door and we reach the end. So that condition is if the yaw increment is less than 0 and the get actor rotation yaw value is less than or equal 0. If both of these are true, then that means we are closing the door and we reach the end. We want to combine both of these conditions in an OR. So if this is true or this is true, then we've reached the end. So I'll just do an OR Boolean here. This or this. If they're true, then we've reached the end, and we want to set should open or close door back to false. So let's test it out by opening the door, doing a delay of like 2 seconds, and then calling close door. Door opens, door closes. Perfect. See it again. Door opens 90 degrees, door closes 0 degrees. Amazing. All right, so let's remove these because we just did them for testing. We don't need the begin play either. And this is our door. So now we need a pressure plate actor that will open and close this door. So let's do the same thing. Let's go here. Let's create a new blueprint class of type actor and call it BP pressure plate. And open it up. So the pressure plate will also have a static mesh. We'll call it the plate mesh. I actually don't have a static mesh that looks like a pressure plate. So side detour, we're going to create it really quickly in the modeling tools, and I'm going to show you how. So you can go in selection mode and click on modeling or Shift 5. And we're just going to get a cylinder here. And the height, let's make it like 5. The radius, let's make it something like 100. And increase the slices, yeah, to something like 70 so that it's smoother. And yeah, that's enough to be our pressure plate. It's just like a plate that you stand on. And let's give it a default material. I think there's this default geometry. Yeah, so the red default geometry, that will be the default material for it. And that's it. We can just save this, and it's going to be added to this maps generated folder. I'm going to rename it to SM pressure plate and move it to my content folder here. All right, slight detour, but we are back now. We can delete this, and back in my pressure plate, my plate mesh. By the way, in this case, I don't want the plate mesh to be the root because I'm going to be adding more components to it, and I want them all to be relative to the root. So we won't drag this on the root like we did with the door. So let's pick our SM door, what's called, sorry, plate mesh here. SM, what did we call it? Pressure plate, yeah. And here is our pressure plate. But we also need to know when the player or any object that can trigger it stands on the pressure plate. So we need a sphere collision here. So search for sphere collision, and we're just going to call it our sphere collision. And remember, we made the radius 100 for this static mesh, so make the sphere also 100 to cover the full radius of our plate mesh. Excellent. And this is our plate mesh. Let's open it in the content folder, drag it here. So now what we want to happen is when the player stands on this plate mesh, on this pressure plate, the door opens, and when the player gets off, the door closes. So let's see how to build this functionality. So first things first is we need to know which pressure plate belongs to which door. So I can have multiple doors, for example, but this pressure plate opens this specific door. How do I tie a pressure plate to a door, tell them that you open this one? Well, to do that, we need to add a reference to a specific door as an instance editable variable in our pressure plates. Let's see how to do that. So on the variables, let's add a new variable and call it the door ref. Ref is short for reference. And this is going to be of type BP door, the door actor that we just created. And it's going to be an object reference. Now click on this eye icon, or up here, make it instance editable. This allows us, so compile and save. This allows us, when we place it in the level, you'll see here, there is this door ref. Now I can select one of the doors from the world, or use this dropper here and say this pressure plate belongs to this door. So now there is a reference to this specific door in my pressure plate. I'm going to actually make it this door and delete these two others. So now, because we have a reference, we can do something with this door. We can tell this pressure plate to open this specific door or close this specific door. So let's delete all of this. We won't need any of these. But what we do need is to detect a collision with the sphere. So if the player stands on the sphere, detect an overlap. So click on our sphere collision, scroll all the way down here, and we have two events for onComponentBegin and endOverlap. So we want to implement both of them, so click them both. So when an actor overlaps with the sphere, we want to check, is this the player actor? Because for now, let's say only the player actor can activate this pressure plate. So let's do a branch and check if other actor is A. There's a function called isA that checks whether this actor is of this class, and the class is third-person character. So this checks if this actor is a third-person character or inherits from a third-person character. That means it's our player. If this is true, we want to also check if our door is valid, because if there is not a valid reference for the door, we can't do anything. So check if this is valid and use the function one, because this returns a Boolean. And we want to combine both of these conditions here by an AND. So if the character that's overlapping is a third-person character and there's a valid door reference, then proceed. Proceed to do what? Well, proceed to open the door. So get our door ref and call the open function on it. And that should be it. So if we play and I stand on this thing, then the door opens. Now if I get off, it doesn't close because we haven't implemented the end overlap. And if I step on it again, it remains open. Actually, you can see here that it keeps increasing in the angle slightly the more I press, the more I go on it. And that's because open door can be called if the door is already open. So we need to fix that really quickly by adding a condition in our door here to check before opening it if it's already open. So first do a branch and check if the get actor rotation yaw value is greater than or equal 90. That means the door is open. So if this is true, don't do anything. So only on false. Well, let's actually invert the condition so it's better to read. So if this is less than 90, then open the door. And we want to do the same thing for closed door. So just copy these. But the condition now is if the yaw value is greater than or equal 90, then the door is open, so please close it. All right, now this issue won't happen again, where it can open more than 90 degrees. Excellent. All right, back to our pressure plate. We want to do the same thing on overlap end, but close the door instead. So let's copy all of this, because this is all the same. If the player ends overlap and the door ref is valid, then get your door ref and call close door. Simple as that. We play, door open, get off. The door did not close. Oh, I must have forgot to plug the objects, of course. Now it should work. Door open, door close. Perfect. Now, one other thing we'd like to do is to change the color of this pressure plate when it's activated to let the player know it's active. So we can do that also pretty simply. Let's add two variables here for the materials where it's going to be open and closed. So this is going to be the default mesh. It's called default plate mesh material. And this is going to be of type material interface. This is what you want, object reference of material interface. And we're going to add another one, call it the pressed plate mesh material. All right, so compile and let's add values for these. So this will be our default geometry red, that's the default one. And the pressed one, let's make it the default geometry green. All right. So when we open the door here, let's get our plate mesh and set its material to be the pressed material, because that's active when the door is opening. And we're going to copy this and paste it here. When we close the door, we want to set it back to our default material. Excellent. See how this looks like? Boom, turned green, door open. Boom, turned red, door closed. And that is mainly our feature. Amazing. So we've seen how to implement it in Blueprints. Now, how do we implement it in C++? And what are the differences and considerations? All right, so to create our C++ class, we go up to Tools here and choose New C++ class. Now, if your project isn't a C++ project, like we started here, you can still follow these steps, and when you finish them, restart the engine, and it will then become a C++ project. But if you already have a C++ project, then this will work just fine. So what we want to do is create an actor here, and I'm going to select actor, say next, and I'm going to call it my, this time we want to create one for the door, but it's the C++ door, so I'm going to call it CPP door. Again, don't name your C++ files with the prefix CPP. I'm only doing this for the tutorial to differentiate between the Blueprints door and the C++ door, but don't name them like that. And then I'll just press create class. Now my class is created and opened up in my editor. Let me open up the editor. Let me also stop the Unreal Engine because we're going to be making changes. And every time you make changes in C++, it's good to restart the engine. I'll also explain the live compiling, but for now, let's just restart the engine. So creating this actor created two files for me, a .h file and a .cpp file. The .h file is called the header file. And the header file in C++ is the structure of your class. So this contains all of your functions, variables, and everything that you will have inside the class, but just as a definition. So functions, you define what's the name of the function, what inputs it gives, and what outputs it gives, and same for variables and so on. But it doesn't implement these functions or variables. The C++ file is what implements these functions and variables. So we have an example here already because this started as a C++ project. So in our source folder here, we have a pressure plate demo character. So this is our third-person character. So it has a header file, and you see here it has a camera boom component, it has a follow camera, it has a jump action, and so on. So these are all the definition of the variables. It has a move look function, so the definition of all the functions, and this is our header file. And then in the C++ file is the implementation of these functions. So what happens when you move? So if blah, 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 get the rotation, set the yaw. So this is the implementation now. And that's the difference. The header file will always contain the definition. So let's close this up and go back to our example. So the first step when we created our blueprint door actor was to add the component for our static mesh. So here we're going to do the same thing. We're going to go under the protected scope here. Protected just means that anything you define under here can be accessed by this class or children of this class, but not outside of this class. So to define our component here, we need to know the type of it. And the type of a static mesh component is static mesh component. And we're going to add a star here because it's a reference. So when in C++ you add a star at the end of a definition of a type, you're saying it's a reference. So because we're going to be referring to a specific mesh here, and this will be called our door mesh, and this is just our name. But we can't just stop here. We need to add something called a UPROPERTY macro. So above the variable, we write the words all in capital, UPROPERTY. Now, this is a Unreal Engine specific macro, and what it does is that it adds some functionality to our variable. This is what's used to expose this variable to blueprints, for example, allow Unreal Engine to know that it should use it as part of its garbage collection, and does a lot more things. But when defining any variable, you will most likely want to use UPROPERTY and then add some options here. For example, one option is called visible anywhere. That means that this variable, this door mesh, is visible in any details panel when you click on the actor. So we want this, and we also want it to be blueprint read only. Now, blueprint read only doesn't mean that we can only read this mesh and not edit it. It kind of gives that indication. It means you can't edit the reference to the mesh after you've added it, but you can read it and modify its variables. So change the static mesh itself. And I'll show you what this means later on, because it might be slightly confusing. And then finally, we just want to give it a category, and category is going to be something like components. This just puts it in the tab components when we open it up in blueprints as well. And now we've created our first component definition. So we've defined the door mesh as a UPROPERTY that's visible anywhere, readable only from blueprints and under the components category. So now that we've defined the mesh, we need to actually add it to our actor. This again is in the header file, so it's only the definition of the variable. To add it to our actor, we're going to go to our .cpp file. And under here, so this is called the constructor, similar to the construction script you see in the blueprints, we're going to write some code here. What we want is to create, is to assign a value to this door mesh. So we defined the variable, but we didn't assign it a value. And its value is going to be equal to, we're going to call something called create default sub object. And by the way, if you see that I have this autocomplete, this is a GitHub Copilot that has context of what I'm trying to do and usually gives very smart autocomplete. But anyway, we're going to call this create default sub object, which is a utility function from Unreal Engine that creates components and assigns them as children to this class. And because we are creating a mesh component that is a child of this actor or is a sub-object of this actor, we use create default sub-object. And then in triangular brackets, we need to pass the type of the default sub-object we want to create. And if you recall, the type of this door mesh is uStaticMesh component. That's the type. So I'm just going to copy it and paste it here. And then we give it a name by opening up regular brackets afterwards, typing text, all capital, more brackets, and add the name as a string called door mesh. And this created the door mesh component now for us. Now we want to make it the root or attach it to the root. So we're going to say door mesh and do a arrow here. So like dash and then this triangle and call setup attachment to the root component. So root is now red because we don't have a root component, but every actor comes with a default root component called root component. So now I've just made the door mesh the root component. And you see here the arrow, this is how you access functions on references. So if I want to get anything, so if I want to get the static mesh, for example, of this door mesh, I'd say like door mesh, static mesh, get static mesh, yeah. So this is how I call functions or variables on a reference. And this is a reference because it has a star here. And we're going to be creating things that aren't references and seeing the difference later on. Let's delete that. So now I can just run the game to make sure that I don't have any errors or any problems with my project. And since the game is starting up, there are no compiler errors, which is great. And now the project opens up normally. Now, let's refresh what we did with our door blueprint here. So in our blueprint, we implemented this tick function that checks for should open or close, and then rotates the actor and then has stopping conditions, right? So we need this should open or close variable as well in our C++ file, and we need the yaw increment variable. So we have these two variables here that we need as well. So let's add these two variables. So again, we go back to our header file, and just under here, we're going to define a boolean, which is of type bool, and call it should open or close. Now, this doesn't need to be a U property because this is going to be a boolean value only accessible from within our C++ class. We don't need to access it outside of this. And same for our float yaw increment. Again, if you recall, this was the value here that we set to +2 when opening and -2 when closing. So both of these values don't need to be U properties. So we're just going to keep them as a regular boolean and a regular float. And now we need to define our open and close functions. So we're going to do this not under the protected, but under the public, because we want any actor or any class to access and call these open and close functions. So when you define a function, you first say what it returns. And if it returns nothing, you say void. So I'm going to say void open door. This is how I define the open door function. And it doesn't have any inputs. Like, for example, the tick has a delta time input. So I'm just going to leave this empty. And I'm going to do the same thing for closed door. Just void closed door. Now, remember the U property macro? For functions, we need something called a U function macro. And this is very important. We're going to add it for both of them. Now, what I want to define in this macro is I want to say this function should be called from a blueprint file. Because, for example, we're going to be creating blueprints and we want to be able to call this function from there. So I go into my U function and say blueprint callable. This is what we want to add here. And we're going to add it for both our open and close. So now we just marked these functions as being able to be called from blueprints, and let's give them a category as well and call it something like actions. These are the actions you can take. You can open or you can close. All right, so now we have our functions, we have our variables, we have our components, and we have even added our component to our actor. Now let's start implementing the open and close functions. So when you define a function in your header file here, you have to go here in your C++ file, implement it. And the syntax is as follows. You say the return value, so it's void, and then you reference your class. So my class is called, and you see here the class called CPP door. Any actor starts with the prefix A. So A is for actor here. So Unreal Engine automatically named this CPP door for me a CPP door. This is very important. This is not just a convention. How you name your actors is very important. So because this is called a CPP door, I'm going to reference it and say a CPP door. And I'm going to do double colon, which means I'm referencing a function, or I'm referencing something from this class, and I'm referencing the open door function. And then just do the syntax. So now I'm implementing the open door function. And we can do the same for closed door. So void ACPP, closed door. And now in here, we do the implementation of the closed door function. So if you recall, in our blueprint, the implementation of open door was simple. It checks if the yaw value of the actor's rotation is less than 90, set the yaw increment, and set should open or close door. So it's no different in C++. We're going to do an if condition. This is the same as branch. And we're going to get actor rotation. And then we want to access the yaw value of the get actor rotation. So we do a dot yaw. And this gives us the yaw value from our actor rotation. And if this is less than 90, then we open brackets and we can proceed. So anything we write here is the true of the branch. So it's following this. So now I want to set these two variables. And that's really easy. We just say yaw increment equals 2.0f, which is 2 as a float, and should open or close equal true. And that is pretty much it. Now we can just copy all of this, and closed door is the same. The only difference is the condition. If the yaw is greater than or equal 90, then set the yaw increment to -2, and that is it. Now, for the tick function, we also do a branch or an if condition and check if should open or close is true. Then we want to update the actor's rotation. So we want to do set actor rotation. Now, this function takes a rotation value. So we need to figure out what the new rotation value is. Now, if you recall what we did here, we just got the current rotation, kept the x and the y the same, added the yaw increment to the z, and that was our new rotation. So we want to do the same thing here. Before setting the actor's rotation, we want to get the current rotation and store it as a variable. So the type of rotation is called fRotator, and we're going to call this a current rotation, and it's going to be equal to get actor rotation. And then we need to make a new rotation. So fRotator new rotation. We're not going to give it a value yet, but we're going to set all of its individual attributes. So new rotation dot roll equal current rotation dot roll, new rotation dot pitch equals current rotation dot pitch, and new rotation dot yaw equals current rotation dot yaw plus the yaw increment. And that is our new rotation that we can just pass in here. And that's pretty much it. Now we just need to apply this, this ending condition. So we checked if the yaw increment value is positive and the door is greater than 90 rotation, or the yaw increment value is negative and the door is less than 0 rotation. So how do we do this? We do a condition as well here and check if the yaw increment is greater than 0, and the and is you just do 2 and signs in a row, and the current new rotation dot yaw is greater than or equal 90. This is our first condition here, and we want to OR it with another condition. So to do that, we just put all of this inside a bracket and do an OR, which is 2 pipes here, and then open new brackets for our new condition. So or the yaw increment is less than 0, and the new rotation dot yaw is less than or equal 0. That is our condition, and if that is true, then should open or close is equal to false. And that is it. So you see, this line is a lot cleaner than all of this mess. So that's also one of the benefits of C++. You have some parts that are much cleaner, but you have other parts that take more code like this. So pros and cons here. And that's it for our C++ door actor. Now, actually, this actor is done. But before we move on to the pressure plate, I want to show you how to use a C++ class in your game. So I'm going to stop and run the project again. And when the game opens up, in my content folder, I'm going to have a C++ classes folder. And inside this folder, I'm going to see here my CPP door. This is the door C++ class that we created. Now, I can just drag and drop my C++ actor in the world, but it is still missing some values, like the door static mesh. That's why I don't see anything. And I want to add them through blueprints. That's why I made the door mesh visible anywhere in our code. So I'm going to create a new folder and call it our CPP actors and open it up. Technically, we're still creating blueprints here, but they're going to be inheriting from C++ classes. So I'm going to right click and create a new blueprint. I'm not going to pick actor this time. I'm going to expand all classes and search for my CPP door, the C++ class we created. And I'm going to select it. And I'm going to call this the CPP underscore door. Again, don't name your file CPP underscore because this is a blueprint. It's not a C++ class, but I'm naming it CPP so we differentiate between the C++ door and the blueprints door just for the sake of the tutorial. But now we have this CPP door and I can open it up and I can see here that my door mesh is there, but there is no value. So I can just go here and add my door. And that's it. So if I drop it into the world, it's going to look exactly as this other door. No difference really. Now, you'll notice that it doesn't have any functions or variables. The graph is empty because everything we implemented in C++ is only visible in C++ unless we expose it, like we exposed this door mesh specifically. But what we also exposed is we said that open door and closed door functions are blueprint callable. That means I can do this. I can call them inside of blueprints. So on begin play, I can just open the door, do a delay of 2 seconds, and then call closed door. So now if I play, you'll see here the door is opening, 2 seconds, closing. So the C++ functions work. And if I double click on one of these, it will take me to my open door function in C++. All right, let's delete this because they were just for testing. But this is basically how you create blueprints out of C++ classes. You can't just drop them in the world. Well, technically you can. So I can drop the C++ in the world, but because the door mesh isn't assigned, it's not going to do anything. Well, I can come here and then assign the door to it. But usually you want to have a blueprint child of your C++ class to be able to add functionality to it. If for any reason you don't need to add any functionality to it, like assign variables or add more blueprint functions, then you don't need to create a child of it. But for our use case, we're always going to be creating one. All right, now let's move on to our pressure plate for C++. So again, we go to Tools, New C++ class of type Actor, and we're going to call it the CPP pressure plate, and create class. And it did the same thing, created a header file for me with all of the boilerplate that I'm going to need and the CPP file for me. So same steps as we did for our door. We need to add some components to our pressure plate. And if you recall, the pressure plate actor here had 2 components. It had a mesh that's attached to the default scene root, and it had a sphere collision that's attached to the mesh. So we need to create both of these. So again here under protected, we're going to add our static mesh component star because it's a reference and call it our plate mesh. And again, we need our UPROPERTY visible anywhere, blueprint read only, and category components. We don't need this meta, but we need these 3. And then we need to create our sphere collision, which is of type U sphere component star as well. And we're going to call it our sphere collision. And we need the same U property with the same three options on it: visible anywhere, blueprint read only, and category components. So one thing I didn't explain about blueprint read only is here. So for example, in our CPP door, I can click on the door mesh and edit all of these things. I can edit the mesh itself. I can edit its materials. So it's not read only. I'm able to edit it, right? Well, actually wrong, because I can't set the variable. So I can't set the door mesh variable here to be something else. I can modify its properties, but that's not editing it. It's not editing the actual memory reference of the door. So blueprint read only means that I can't change this reference to refer to something else. So that's very important. All right, so now that we've created our components, we want to attach them to the actor, just like we did with the door. So we go here in our constructor, and this time we don't want to, so for the door, we made it the new root component. This time we don't want to do that. Just like we have here, we want to have a scene root as the default root component. So we're going to do that first by going here and saying root component equals create default sub-object. And the type of the default sub-object is U scene component, and we're going to call it default scene root. And then we're going to create our plate mesh. Again, create default sub-object, give it the type static mesh component, and then give it a name. And we are going to attach our plate mesh by calling setup attachment to our root component. And then we want to create our sphere collision. So sphere collision is equal to create default sub-object of type U sphere component with the name sphere collision. So this is red because it's telling me that I didn't add an include components sphere component.h here. So whenever you use a type or another class or something like that, you need to include its header file in your implementation so that the engine knows what you're referring to. So I'm just going to go up here and say include and do components / sphere component. Nope, not actor component. Sphere component.h. And now it's going to stop complaining. Now we just need to attach our sphere collision. Instead of the root component, we're going to attach it to the plate mesh. And we also want to set its radius. So sphere collision set sphere, oh no, wrong one. Set sphere radius to 100. Excellent. Now back in our header file, we need to define a few more variables. So if you recall, we had the door ref, we had the materials as variables as well. So let's first start with our materials. So again, it's going to be of type U material interface, and it's going to be a reference as well. We're going to call it the plate mesh. Was it what did we call it here? Default. Okay, I'm going to call it the default plate mesh material, and this also needs to be a U property, visible anywhere, blueprint read only, and category. Let's add it to the materials category. And then we'll just copy this and paste it. And the other one is going to be, instead of default, it's going to be pressed. I had caps lock on, pressed. And now we've created our two materials. And also they are in the protected scope, so that is correct. All right, and I see a warning here that's telling me that I didn't import the USphere component. So I need to also add this includes USphere component as well. So I can just automatically let the editor do this for me. And now that warning is gone. Now we need to add our door reference. So the door ref, we're going to add it in public so that any actor or any class will have access to this door. And the door is of type ACPP door. This is our C++ door actor. And again, it's a reference, so we add a star, and we're going to call it our door ref. Now it's going to tell me you also need to include it. So I'm going to say, fine, add the include cppdoor.h here. And this also needs to be a U property. And instead of visible anywhere, we're going to make it edit anywhere, because we want to be able to edit the actual reference to the door. So this needs to be edit anywhere. And that's it. We're just going to give it a category. Let's call it something like config, short for configuration. Now, before moving forward, let's look at what this looks like first. So I'm going to stop and play again, make sure we don't have any compiler errors, and also create a child of this pressure plate and see what it looks like in the world. So the editor is starting, that means no compiler errors, and the game has opened up, which is great news. So now, again, we have our C++ classes, we have CPP pressure plate now. So I'm not going to add it directly through a C++ class. I'm first going to create a blueprint child of it. So in our content folder, C++ actors, blueprint of type CPP pressure plate. And I'm going to call this the CPP underscore pressure plate. Again, don't name them CPP underscore like I mentioned before. Now, the plate mesh, we just give it our static mesh pressure plate that we created. And there are actually two things. So first of all, if you don't see the variables that you defined here, click on this icon and say show inherited variables. Now I can see my materials, my components, and everything here. Now, I made a mistake, and I'm going to show you the mistake here. I want to assign these materials. So just like we did for our other, where is it? In our blueprint actors, in our other pressure plate, we clicked on these materials and gave them a value, right? So this one was the red one, this one was the green one. I want to be able to do the same for my C++ pressure plate. But you see here, I can't click on this. That is because I made it blueprint read only instead of read write. So if I go back to my editor, these read onlys, I'm going to make it blueprint read write for both of them. When you make small changes, you don't have to close and open again. You can use Unreal Engine's live recompiling. The shortcut for it, I think, is Control-Alt-F11. Yeah, that's the one. And if you don't want to use the shortcut, you can just also go to your level and click on this icon here. This recompiles and reloads live. Now, if I click on these materials, I am still unable to edit them. Yes, that is because I made it visible anywhere, and visible anywhere can't be edited. So this has to be edit anywhere. So again, these are two important things that work together. So this will be edit anywhere and blueprint read write. So that means that I can change the reference of this variable from any window. So back here in my engine, now I can change it. So this will be our default geometry green, and this will be our default geometry red. All right. So now I can also place this actor in the world and search for my door ref, and I can select now this door. So remember that we made the door reference a CPP door. That means that I can only choose this door, and I can't choose this door because this is not a CPP door. This is a blueprint door. So I'm just going to click this one and choose my door. And now I've assigned the reference to it. The door didn't have any problem because it was already edit anywhere. So this works perfectly. Now we go to the slightly complicated part, which is adding the sphere collision. So let's just open up our blueprint pressure plate and remember what we did here. So we clicked on our sphere collision, scrolled down, and implemented this on component begin and end overlap. As soon as we clicked it, it created an event for us with all of these inputs. This is called the signature of this sphere, of this overlap event. So the signature means all of the inputs it needs to take, sorry. And this is the signature of the on component end overlap. So it needs to take a component, an actor, another component, and an integer. If it doesn't have this, the signature won't match. So what we need to do is create two events with a matching signature and then bind them to the sphere in C++. So how do we do that? Well, we just create two functions as we normally would. Let's do them here under the protected, because we're only going to be using them inside this class. So it is a void function because it doesn't return anything. And I'm going to call it on pressure plate pressed. And we're going to create another one for on pressure plate released. And now we need to add all of the inputs that match this signature. So we need to add the component, the other actor, the other component, etc. And it's going to look something like this. So we have a U primitive component. We just give it a name. We have an actor. We give it a name. We have another U primitive component. We give it a name, and so on. The components and the actors are references, so they have a star. And this F hit result has an AND next to it. That means that it is passed as a reference. So that means that it's not a type that is created. So here we're creating something, but no, this is passed as a reference. So I've been calling this a reference so far, the star, but it's good to know that a star after a type is called a pointer. So this points to a place in memory, whereas this is a reference to an actual existing entry in memory. So that's the difference between star and AND. But you need to add all of these to match the signature. And same for pressure plate released. Its signature is slightly different because it only takes component, actor, other component, and index. So then it's going to look something like this. And by the way, they can all be just one line. That's fine. But I like to split them on multiple lines so that it's easily readable. All right, so we created our two functions, and we need to make them U functions as well. So add the U function macro to both of them. We don't need to add any property to the U function. We don't need to say blueprint callable or read only or something like that. But we do need to say that they are a U function to be able to bind them to the sphere overlap end events. Let me show you why. So I'm going to go to my CPP file here. And right after I've done all of this in my constructor, I'm going to go ahead here and say sphere collision. And I'm going to say on component begin overlap. So this is the same bind that we did earlier. And I'm going to add a dot, add dynamic. Add dynamic takes a U function to be called when the on component begin overlap event occurs. The syntax here might be a bit confusing, but the first parameter is called this, which is a reference to self. And the second parameter is a reference to the pressure plate function from this class. So self refers to the scope we're currently in, and this refers to the on pressure plate function. And we need to do the same thing for sphere collision end overlap. So on component end overlap, add dynamic, and this one is on pressure plate released. So this is binding to the events. This is the same as going here and saying, getting my sphere and saying a bind to on component begin overlap, and then passing a function. We say create function with a matching signature. So here it says there is no function with a matching signature. I can't select it. So I can say create it, which creates this function for me. Now I can go here and select it. This does all of this for me. It creates the function and binds automatically, but this is how you would manually do it. I don't need to do it, so I'm going to delete all I've done here. But now you understand the equivalent of it. Now what we need to do is implement the events. So we have them, they're bound to the events of on component begin and end. Now we just need this implementation. So again, to implement it in our CPP file, we go here and we say void on component, sorry, what was it called? On pressure plate pressed. and we still need to pass all of the, we need the whole signature as well. So I'm going to copy it from here, take all of this, paste it here. And same for the pressure plate released. Thank you, GitHub Copilot, for automatically doing that for me. Now, the first thing we checked is if, again, if you remember here, we check if the other actor is a third-person character and the door reference is valid. This is our condition to open the door and then modify the material. So to do that, I'm going to do an if condition and check if other actor and do an arrow and say is a. And now I need to pass a reference to my third-person character class. So here we passed a reference to it like this. So if it's of type BP third-person character, but how do I get this object class reference in C++? Well, to do that, I'm going to say a CPP, sorry, what was it called? So this is our plate demo character. This is the class that we want to check. This is actually the parent class of the third-person character. So I'm just going to copy the name of the class, which is a pressure plate demo character. I'm going to say if it is a pressure plate demo character and do 2 colons and say static class and then open brackets. That's how you get a reference to this as a static class. Again, it's going to tell me I need to add the include for it. So I'm going to ask my editor to do that, which adds this line for me, include pressure plate demo character.h. And that is the first part of our condition. The second part was if door reference is valid, right? I just add and door ref. So just the name of the variable itself. And this already does an is valid check on it because I add it as a logical operator. When you use and or the ors, you're saying that you want to convert this to its Boolean value. So if it is valid, it's true. If it's not valid, it's false. But why is it red? Cannot resolve symbol door ref, but I have the door ref here. So this shouldn't be, that is because I didn't add the name of the class when defining this function. So that is not CPP pressure plate. So we need to make sure that we're referencing the function from this class, otherwise it won't know what door ref is. Okay, so now I'm checking this condition. That's the same as my condition here. Now we just need to open the door and change the material. So to open the door, that's very easy. We get our door ref and say open door. Now how do we change the material? GitHub Copilot knows what I want to do, and it is exactly that. So we get our plate mesh, call set material, material index 0, which is here as well. This means that the first material. Set it to our pressed plate mesh material. Excellent. Now we want to copy this condition, paste it in our on pressure plate released, and change this to closed door, and change this to default plate mesh material. And that should be it. If I live compile by Control Alt F11, go back to my game, play, stand, door open, door closed, material changes, beautiful. Blueprint 1 still working, why wouldn't it? And C++1 working just the same. Amazing, and now you know how to create the same feature in both Blueprints and C++. Now, I promised in the beginning to show you how Blueprints and C++ usually work together and how to make them serve each other instead of just being a replacement. So right now we have created our Blueprint file that inherits from our C++ class. Now, one thing that maybe you want to do as well is create functions that are overridable. So right now, for example, in my pressure plate, if I go to override, I don't see any of the functions that I've created. I can't add functionality to them in Blueprints. But for example, let's say when the pressure plate is pressed or released, I want to be able to add more functionality other than just what happens here, but only in Blueprints, or maybe additionally in Blueprints. So I can go to my header file here and add to my pressure plate pressed function something called Blueprint native event. Now I'm going to add it on both, and the editor will complain, saying that the function is not implemented, even though the function is implemented here. But when you add Blueprint native event, you basically change the name of the function to be the same name, but underscore implementation. Now the editor will stop complaining. So this means that I have created a function that can be implemented in Blueprints, but also here is its default implementation in C++. But if I now live compile, and it succeeds, and I go back to my editor, I will see here in the override panel my two functions on pressure plate pressed and released. So I can click one of them. What this will do, so right now, if I click both of them, I've just overridden both of them. That means that when I play, this pressure plate won't do anything because I've overridden the functions in Blueprints and told them to not do anything. If I want them to continue doing their default behavior, I can right-click and say add call to parent function. So add call to parent function, and then just connect all of the pins, meaning do what you already do in your parent function. And the parent function, well, the parent is the C++ class. So meaning do what the C++ class is already doing. Now if I step on it, it works. So now I can add functionality next to what the parent already does. I can do a branch and say, well, if this other actor is a, no, wrong one. This other actor is a third-person character, then what I want you to do is, I don't know, set the actor's location to be equal the current actor's location. Let's split it and split this one. So keep the X and the Y the same. Let's, I don't know, decrease 4 or like 3 from the Z. And let's do the same here. Let's do a branch, check everything's the same. If the other actor is a third-person character, then return this back to 0. It is going down, and then going up, and then going down. So you get the idea. I've added more functionality to this pressure plate in Blueprints while keeping the C++ functionality still intact. So this is a way to generally implement your core functionality in C++, but then allow you or your game designer, depends on who's going to be working on it, to add quick iterations in Blueprints. So the core functionality, which depends on performance and scalability, should be in C++, but then you want the option to add additional iterations and more functionality in Blueprints that would be otherwise slow to do in C++. So this is generally how they work together. Of course, there is a lot more you can do, but this is just an idea of how you can make Blueprints and C++ work together. Mostly it's through these macros, by defining certain things as editable, by defining certain things as visible, and certain things as read-only or read-write. You are adding a structure to your code, a structure to your game. It enforces maintainability and allows you to scale much, much easier. And that's it. We took a simple Blueprint setup and rebuilt it entirely in C++. We learned the difference between the header file and the CPP file. We learned how to define functions and variables using the UPROPERTY and UFUNCTION macros. And we learned how to expose options from C++ to be edited and extended in Blueprints. The takeaway here is that C++ and Blueprints aren't rivals. They are teammates and they're meant to work together. You should be using C++ for the core foundations of your game and the performance critical parts, and then use Blueprints to quickly tweak, test, and build on top of that foundation. And finally, if this video helps you get more comfortable with C++, let me know in the comments below if you want more of these videos, if you want more C++ tutorials. And as always, if you've enjoyed it, please consider giving a like and subscribe. It really helps out the channel a lot. And I will see you in the next one.